Welcome to the advanced lighting session. My name is Jerome Platteaux. I'm the lead artist at Epic Game. I've been at Epic for a little bit over 2 years. Before that, I was a CG supervisor at ILM, Industrial Light and Magic in San Francisco. So today, what we're going to try to do is figure out what is the best way to light a project in Unreal Engine. So there's a lot to cover today, so I might go a little bit fast. I have 200 slides, so bear with me. So overall, quick technical and artistic decision that you have to make. What are the best way to prepare your asset and your scene? And then we're going to cover the baked lighting setup, the dynamic lighting setup, and the image-based lighting setup. And then we're going to talk a little bit about the shadow, what are the tricks that we can use, and then the overall reflection that we have, or the solution that we have in Unreal Engine. So first of all, a technical question. Of course, what is your target media? So are you targeting for a mobile? Is it so it might be just the lowest GPU power you can get? Or are you going to have a project that is more VR oriented, meaning like it's going to be the most demanded? You have 90 FPS per second, and on top of it, it's in stereo, and it's slightly over 2K, so very demanding. Or is it a project that is a real-time cinematic, so that it requires the highest fidelity for your project? So the best anti-aliasing, and then the sharpest reflection and all that stuff. Or is it the good thing with those type of projects, like the cinematic and the real-time film, is they could be optimized per shot, so you can put all your effort and all your light for just what is visible in your shot. So it's another good thing that those type of projects have. And then those projects also could only be 24 FPS. As you know, the movies are shot in 24 FPS. So that's a lot less demanding than a VR project that's 90, or even like a game that's 60. And then some other projects don't even need to be completely real-time. You just look for interactive workflow, like being able to do your lighting and be able to work in engine. But if the final image takes a little bit longer, it's not a big deal. So that type of project exists too. For example, in movies, ILM did render the K2SO on those two shots, and they were actually taking slightly over a millisecond. So they were working almost in real time on the desktop. But when they were about to do the render, they were actually rendering in higher resolution with all the parameters maxed out, basically. Also, one thing that you have to think about is the overall game or project is static. So that means you can bake your lighting, which is another good thing to have. Or in that case, for example, for Fortnite, the lighting needs to be constantly reevaluated. Things are destructible, or you spawn new asset, so the lighting is constantly changing. And then sometimes nothing is moving, or almost nothing, but it's just too big. Like you have an open world, so you cannot bake. So it would take hundreds of thousands of texture of light maps. So you have to go with the dynamic lighting for something like an open world, for example. And then, of course, what is the target hardware? Like, is it like a consumer hardware, like console and a regular PC? For example, for Robo Recall, when we did that project, we know we had to hit the minimum spec that was required by Oculus to make sure it runs. It was a 970 at that time. Or you have sometimes more specialized project, like ILM did a project where they did a VR project. It was only shown in museums, so they were completely in control of what is the final spec that they're going to use for the PC. So they just jam a bunch of hardware together, and then something that would cost way too much for a regular consumer. And also, one other big question when you start a project is, what renderer do you want to use? Do you want to use the deferred renderer or the forward renderer? And then what are the differences and how it works globally? So I'm just going to go over a very simple explanation about that. So deferred renderer. So deferred renderer is the default renderer for Unreal Engine 4. So the way it works is you store all the raw data into a screen space buffer, like a show on the top right. So once all those are stored, then you compose them back all together, and I give you the final image. And then also an important thing is the lighting is evaluated at light draw time. So that means they evaluate the light all at once, kind of. And then the extra screen space data can be used for more sophisticated post-process effect and simpler combination of lighting method. For example, we use all those extra data for the screen space AO and ambient occlusion, and then screen space reflection. And it's the golden path for Unreal Engine. It supports all the rendering features. So any project is really recommended to go with the deferred renderer. For the forward renderer, why would you use the forward renderer? So it was developed for VR in mind when we were shipping RoboRecall. So all the lighting and shading is evaluated at object draw time. So that means the more you have light and the more you have object, the more he has to evaluate that. So one object with 20 lights is going to be, of course, a lot more expensive. And also the good thing with the forward runner is that it can do very specific optimization. So we can turn on or off the evaluation of the roughness, or we can have some very cheap reflection evaluation on certain shaders, specific shader. That's an option that you can turn on and off per shader. And then you have another anti-aliasing option that is great for VR is the MSAA, because compared to the TA. So because in VR, the headsets are already slightly blurry, you don't want to use the temporary that would tend to blur even more. So we use the MSAA. It gives you a sharper image, so you don't lose any extra detail in your pictures. So how do we prepare our asset for a good lighting? So obviously, the first thing is make sure your materials are physically correct. So most common mistake that we see is the base colors are always slightly too dark or slightly too bright. So watch out for those parts. And then we see a lot of people doing metallic at 0.5 or not completely 0 or 1. Think about metallic as a mask. It's like it is a metal object or a non-metallic object. And then same thing for specular. We see people putting color in specular, but it's actually just an intensity of it, the reflectance intensity. If you actually want to adjust the color of your specular, it's actually back to the base color. So overall, we have two types of material. We have the non-metallic, also known as dielectric and insulator, or the metallic material, so the conductor. So as you can see, you have a lot of reference on the internet to know what are the most used value for the base color on non-metallic material. So of course, on the non-metallic material, you have a lot more range compared to the metallic material. The metallic material tends to stay around the same type of range, like very, very bright for the pure material, what I mean. And then just to give you a global idea, like the charcoal, which is overall the darkest thing, one of the darkest objects that we have in our assets, is a RGB value of 0.03. And then that's what I mean by not going too dark. Like it's never purely black. So there's always a little bit of information in the dark. And then same thing for the white part, the bright part, is it's never completely white. You never have anything that is pure one. So example, the snow is in theory like around 0.9. That's a small interesting fact that gives you an idea. Like those are actual photos, and that shows you that that's the darkest substance that we can find in the world. And as you can see, it's actually not completely black. There's still a little bit of information, but something that is close to zero. That's how it looks in real world. It looks alien. It looks really, really interesting. And then the pure metal is, just to give you a rough idea, they tend to stay pretty bright in terms of RGB value. So bear that in mind when you prepare your asset. Try to stay as physically correct. And then how to prepare a scene for a good lighting. So first of all, when I start to do a lighting, I want to make sure I remove the auto exposure, because you want to make sure the lighting is not adjusted, or the intensity of your picture is not adjusted automatically by the engine. So turn off the auto exposure. Also, time to deactivate the screen space ambient occlusion and the screen space reflection. So by doing that, you don't have anything that comes and darken your shadow, and then you know exactly how they should look like. And same thing for the reflection. You only work with the reflection capture first, and then when you're happy with that, then you turn on the reflection, the screen space reflection. And then I tend to keep the, I try to keep, or I recommend to keep the default tone mapper. I know some people, for example, tend to make an image that is slightly too dark, and then instead of brightening up their light, they would go into the tone mapper, start to brighten the tone mapper. It's a very, very last-minute adjustment. I would say don't touch the tone mapper unless there's a really good reason for that. And then, of course, I tend to remove the vignetting so that there is nothing that darkens my image. And then also, I turn off the bloom so nothing comes and contaminates any lighting on top of it. Then I recommend to always create a chrome sphere. The chrome sphere is something that you can place in the world. That's a good indication. I use a pure mirror chrome sphere. So what I mean is like the base color is at 1, the metalness is at 1, and the roughness is at 0. So that means that it purely reflects what is the reflection captures, basically. So I know exactly how my reflection is going to look like in the world. And then I create my gray sphere. We call it 50% gray. So what does that mean is like on screen, it looks like a half gray, 50% gray in sRGB. But the value to get that is actually in linear is a 0.18. So if you set up your material with a 0.18 value in the base color, that's where you're going to have a 50% gray on the material detail. And then I set up a directional light set at 314 pi. So basically, this light, let me check. So now here you have a color. We can verify what I'm trying to do is I'm trying to create a normalized lighting. So what it does is I see my material being at 50% gray, 0.18 in linear. Then with my light, my directional light set at 3.14, I get the same value in the viewport. So I have my triangle that's working. I have my material that looks the same in the world, and that gives me the intensity of gray that I want to. Okay, what is the difference and what are the advantages of backlighting versus dynamic lighting? So of course, backlighting, you have GI, you have cheap shadow. They're actually not even evaluated because they are baked. And then it's globally less GPU demanding. And then the cons is you have, of course, slower iteration. So every time you change something, you need to rebake. It's static. That means nothing moves, basically. If you spawn another asset, it would just not influence the lighting yet. And then it's more demanding in memory because, of course, all the light bake of the light maps are actually baked and then stored in memory. Sorry. And then dynamic lighting. So what are the advantages of that? It's what you see is what you get. So basically, whatever you move, whatever you adjust is what you see on screen. And then you don't have any surprise when you bake, basically. So the good thing also is it's not static, so you can it's completely real time, so you can adjust everything. The big cons is no GI. It's just too expensive right now. We don't have anything to actually calculate the GI. And it's obviously more GPU demanding. Okay, what is the default light baking setup? So what is the default used case? So usually start with the directional light set as stationary. Then you do the classic Lightmass baking, so you start to see some GI appearing. It's not very clear on the screen, but you get GI bouncing around, light bouncing around. And then another thing is just add the sky dome static too, and that gives you globally the overall lighting that you need. So just going over the light maps. What are the light maps? So light maps they store the lighting information and they are packed into textures. So basically, if you go into the world setting, you can see all your light maps at the bottom right, basically. You can see each one. Each light map is actually a collection of HDR textures. And then on top of it, it's not just the intensity of the light, it's also store the lighting direction. So sometimes people want to use, for example, V-Ray and then bake the lighting and then use those black and white maps or color maps and then import that into the engine and they assume we're going to get the same lighting. You need actually extra more information. You need the lighting direction because we use a combination of those two maps to create more complex. We use that for the normal and it's just lots of things happening under the hood, basically. Light map resolution. So light map resolution is it's an important thing to do when you are in the when you're baking your lighting. So, of course, the lower they are, the faster it is to generate. So you have faster iteration, but also you get a very soft shadow. So globally, a lack of shadow definition. And then with a higher light map resolution, it's of course slower to generate, but you have a way better shadow definition. Just want to show you between the two. One is clearly defined compared to the other. And then something that people still do is actually generate those light maps outside of Unreal Engine. They use, for example, like 3S Max and do the unpacking in it. We have now a really good algorithm inside Unreal Engine, so I basically don't even go outside of Unreal if I want to repack those light maps. So I recommend to stay in Unreal, especially because sometimes an asset that was used for something far is now used super close, and you want to repack the UVs. So stay in Unreal. It's just a lot more faster to adjust that. And also, I recommend to do try to get the unpacking as tight as possible. First of all, because you don't waste that much pixel. So between those each island, you don't waste the pixel, and then basically that gives you a better shadow definition for the same resolution. Always think also like there's the minimum light map resolution is always needs to be inferior or equal to the light map resolution. You have two parameters to set, and usually I keep them almost all the time together, the same value. Lighting types. When you are baking the lighting, only two types of light are baked, so it's the static and the stationary one. And then one thing to know is like the directional light, the point light, and the spotlight are the only one who emit photon for now. And then the skylight doesn't emit photon. So what does that mean? So because they don't emit photon, there's actually not there's only one bounce. So that means, for example, for this part, we should have actually a lot more light coming into the dark area. But because we only evaluate one bounce on the skylight, it stays really dark. Lightmass setting. So the obvious area where you can actually improve the quality of your lighting is if you go to the building tab, you can go from preview to production. But the other very important one are in the world setting. So you have static lighting level scale, indirect lighting bounce, indirect lighting quality, indirect lighting smoothness, light sample placement, light sample placement scale. And then we're going to go over each one. NUM indirect lighting bounce. So what is the idea? Is just tells you how many times the light is going to bounce around. So just to give you an idea of with zero bounce, so that means it's only direct lighting. When you start to bounce 1 time, 2 times, 3 times, 5, 10, and 20. As you can see, when you start to bounce over 3 to 5 times, you don't see much of a difference. Even to give you an idea, like sometimes, I mean, most of the time in movies, they don't bounce more than 3 times because it starts to be very expensive. The good thing is our engine doesn't take much longer to bounce 100 times. So people tend to go crazy on that. I don't think it's necessary. You stay around 3 to 5 and you're good enough. Static lighting level scale. It's in world setting again. So what is the difference between that? So the idea is like, going back again, the idea is like by reducing the scale, you tend to evaluate to a smaller portion of the world. So you get, by reducing the scale, you actually sample more in the world so that you start to pick up more and more detail. But you also get a lot more noise. But I'm gonna show you how we get rid of that. So the indirect lighting smoothness. The idea with that is, going over again. What we try to do with that is actually try to smooth, so per object, the amount of noise. So let me go back again. By default, it's at 1. And when you start to go too high, it tends to smooth too much. And you start to get actually lighting bleeding. You start to get the corner and the dark area bleeding into the bright area. So I tend to stay between 0.7 and 1 for those values. Indirect lighting quality. So basically, it's increasing the number of rays for the final gathering. So this is with a building time set to medium. Going back again. So by default, it's 1. You can see it get rid of most of the noise. But of course, you can see also that it takes a lot more time. And then lighting building quality. That's the one I was talking in the build tab. So it can go really quickly high between high and production in terms of time. So I actually work a lot in preview. Sometimes I check if it looks good in medium, and then maybe over the weekend I go in high or production. And then, oops, those are the rules that we try to stick with. So basically, is the static level scale multiplied by the indirect lighting should stay roughly around 1. So what I mean is, like, if we try to get a lot of detail, so we put the lighting level scale at 1, but because of having a very small scale, we tend to introduce a lot of noise. So that's why you want to increase the indirect lighting quality. So if you get those two numbers, multiply them together, and stay around 1, you should be somewhere pretty clean in your lighting overall. Another thing important to know is that the most like time-consuming part of it is the indirect lighting quality. So static level scale doesn't influence that much on the building time. The indirect lighting bounce is actually pretty low overall on the building time. And then direct lighting smoothness, it's barely noticeable on the building time. The most important one is the indirect lighting quality. Volume light sample. So, of course, when you build and bake the lighting, now everything is static. But if you spawn an asset in the middle of it, he needs to pick up the lighting that was actually baked. So we use the volume light sample scale. It's a bunch of little spherical harmonic that are placed into the world that is picked up by the movable object. And then by reducing the static lighting level scale, you increase the amount of lighting, the probes, those little probes in the world. Lightmass portal. Those are actually something that we tend to forget. but they are very useful. So this is an image that was, it's globally lit by a skylight. And then you can see in the middle, there's actually a small, the door, and then there's a small portal. So that portal indicates to the renderer where to focus most of the photon and focus most of the sample. So without the portal, with the portal, you can see on the corner, you start to see small noise appearing. It's even more obvious on this image. You get a lot more noise. So whatever you can, try to add some portal. It's very useful for windows, doors, and then, but when you get to an area that's way too big, they barely influence. So keep for something that's actually that smaller size. Lighting scenario. So what is the idea with the lighting scenario? So sometimes you want to have multiple lighting scenarios at daytime and nighttime, and you want only to manage one environment. So the way we used to do is actually having two environments, and then one for the daytime, one for the nighttime, bake the two, and then depending on which level you want to load, you load the daytime or the nighttime. But that means anytime you change something in the daytime, you need to change it also in the nighttime. It was just a nightmare. So the good thing now is you just manage one environment, and you store all the lighting information in what we call the lighting scenario level. So all the light maps are saved in that lighting scenario level, and then you have one for the daytime, one for the nighttime, and then you just load the one you need. And then the big thing is you only have one lighting scenario loaded at the time. You cannot have the two and then maybe do a transition between the bright, the daytime, and nighttime. It's a feature that we would love to have, but not yet. And then also having daytime and nighttime, at least for Robot Recall, it gives us more variation in terms of like having a player in this environment is kind of rediscovering the environment with a new eye. And then it was also introducing a different type of gameplay. People tend to play slightly differently at night than in the daytime. Sorry. So how to do that? It's pretty simple. You just put all the lighting information in your sub-level, and you just right-click on it and then change it to lighting scenario. So it would convert all the sub-level into a lighting scenario. Things to remember is only one lighting scenario at a time again, and then also all the reflection capture that you have in your level, they're actually regenerated at loading. So that means for the nighttime, it's going to look at recreating all those reflection capture for the night, and then recreating them again for the daytime at loading. The goal would be to actually store those information and then not having to recapture that, but that's a feature that will come one day. So all the bake lighting scenario that we have right now, our setup, was used actually for the Paragon game and also for Robot Recall. Let's go over the dynamic lighting setup. So classic setup is the actional light set to movable, sky dome set to movable. As you can see, it's overly bright. So that's why you need to activate the distance field ambient occlusion. And then on top of that, we add screen space ambient occlusion. It's kind of like adding a smaller detail, smaller, finest occlusion for the smaller detail. So what is a distance field? So distance fields, they store the distance to the nearest surface at every point. So they are stored in each asset. So to do that is you go into the project editor and you say, hey, generate the distance field for each asset. And then you're going to start to see Unreal Engine building those distance fields for each asset. When it's built, they are stored in each asset, and you don't have to rebuild them every time you open the engine. You just save with the asset. When you put them all together, that's what it looks like. So those they can be used for a lot of different things. So they can be used by default for generating the distance field ambient occlusion. We call that the DFAO. It's the default one that is used in a Skydome. But you can also use those to generate your own AO, for example. So in the material editor, you have way to access those distance fields, and then maybe you can create a material function and plug that back into your distance field AO. The big difference between those two techniques is if you look at the distance field for the generated by the material editor, in the material editor, it's using the most simple way to evaluate that. It's just, hey, how far each pixel is from, how far each object is from the other asset. So you just get a gradient based on that. And then in the DFAO, let me look at it again closer. The DFAO is something that's actually more interesting because it gives you like that dome effect that we get when you go and outside and you get that sky AO kind of. Going back again. When you use purely mathematical way, it just give you distance, so it's very linear, and then the DFO give you that dome, more natural looking. The distance field can also be used to generate the soft shadow. So by just adjusting the radius of the spotlight, you can see it's using the distance field to evaluate that ray trace soft shadow. Here's what it could look like. So I give you that really, really nice shadow, but it's sort of more it's pretty expensive. And then also people use those distance fields to actually generate some sort of soft body deformation. So it can be used for a lot of other things. Things to know about the distance field. So they are only for static mesh component. And I would recommend to avoid huge non-uniform scaling. When you go too far, you start to see some artifact. And then also, when you have really large objects, they will start to have very poor distance field resolution. So you might have to break them into smaller pieces. And then the ambient occlusion is actually the update is actually spread over several frames. So you don't have instant AO. It's barely noticeable. But you can also, to fix some of the artifacts that you can see on the left, there's some black part that are under the arch. You can just increase the resolution for the distance field. And it should get rid of those artifacts. The DFAO can also be tinted. So if you want to fake a sort of bounce coming from the ground, you can actually make it slightly bright and tint it to the overall color of your scene. It's not very obvious on this monitor, but I swear it's brighter. And then that technique, the dynamic lighting setup, was actually used for the Fortnite game and also the trailer that we released a couple of months ago. Let's go over the image-based lighting. So that's a project that we did 2 or 3 months ago that was done to show off the new composure in Unreal Engine. So those are plates that we filmed at the headquarters at Epic. And then the whole idea was just to integrate a CG character on top of it with interactive shadow, and then based on the lighting that is captured on the scene. So how do we do that? First, we need to set up the scene. So make sure we have a plane to cast and to receive the shadow. And then we have the backplate that was filmed. We did some tracking. We construct the camera, imported all those cameras inside, and used the new composure from Unreal Engine. So the composure is it's kind of like the Nuke version in Unreal Engine. What it does is take whatever backplate that you have, and then you can start to compose CG on top of it, or the other way around. So it's done. It's globally one directional light, and then a skylight with an HDRI plugged into it. And then because we use composure, composure is actually using a lot of render targets. So you have the render target for the background, you have the render target for the character, another render target for the shadow, and then we start to compose all that together. The shadow is used to color correct the back plate. So by using more and more render target, you start to fill up the memory really quickly. So we don't have any more render target to generate the shadow for the character, the extra AO for that. So we just use a blueprint that just follow the character footstep and then darken those areas. It's very subtle, but you really need those ones. And then on the left, that's the shot, that's the backplate, and on the right, that's the HDR that was captured. So of course, make sure those match perfectly. So all the value for the dark are correct. And then since the character was going from the dark side to the sunny side, we actually capture two HDR, one in the sunny side and one in the dark side, make sure those are aligned. And then the idea was to lerp between those two when the character goes from the shadow to the sun. So how do we do that? We actually have a way to, we do a blueprint, and then the blueprint tracks the position of the character in the world. And then we also define where is the shadow happen, and then if it's on this side of the shadow, then activate that lerp. And then basically transition between those two. So that technique was used basically for the human race demo. So except they didn't have to lerp between two HDR. The good thing is they have that cart, and then that cart was driving around the roads and then capturing an HDR. So they had a sequence of HDR. So instead of having to load two HDR, they just load a sequence of HDR and constantly updating the lighting. And then they were changing, for each shot, they was changing the sequence of HDR. Shadow map. How does it work? Just a quick recap. So how do we go from the left side to the right side, knowing that we only have one directional light coming from the left? So from the point of view of the directional light, what we do is we capture a depth map. So what the idea is just give you kind of like a Z gradient. And then we reproject that depth map, and then we do a depth test, and then that gives you an idea of if an object is, a part of the asset is in a shadow or not. Why I'm talking about that is important to know that the resolution, of course, of your shadow is very important. You go from something that could be very pixelated or way too smooth, and then to something that is really nice and sharp. So, of course, that comes to a cost. But also, one thing that is important with shadow map is the bias. So when you have a pixel that is kind of covering part of the asset that is in the shadow and in the bright at the same time, you end up with those kind of artifacts. So how do you fix that is by actually pushing the shadow map inside the object, and then you start to get rid of those artifacts. So right now what we have on the left is a lot of artifacts, and then by pushing the shadow into the ground, we lose those weird artifacts. It comes to a cost. It comes to a problem. Sometimes it gets problematic. For example, when you have a bias that is too big for a small asset, then you start to get those light leaking that you see on the left of the character. So when you light something that's small, you want to make sure that you have the bias as small as possible. And then when you have to light something that's really big, this is why you have to increase the bias. But you have to know that your character that is using the same shadow map will start to have some light leaking in your face. So this is a trade-off that you have to figure out. Like it's either I'm focusing more on the character, and then make sure you have maybe some specific light for the character with the smallest bias as possible. Cascade shadow. So it's used a lot. We use that a lot, of course. What is the idea behind the cascade shadow is when you have a a large surface to cover, then to create shadow, you might use only one big shadow map for all that surface, and then it starts to be pixelated. So the idea is actually to cut that large one into 3 little pieces. So you split the camera frustum into pieces. So it allows a higher resolution for the nearest part of the shadow, and then it goes lower and lower over the distance. How does it look like in real time? So you have the red part that is high resolution and just really focusing on the close part, and then etc. It goes in a lower resolution over the back and cover a bigger distance, basically. The problem with the cascade shadow is that when you start to go and pull back, and sometimes you start to see those very weird artifact where it goes from a cascade shadow that is high res to another one that is still kind of the same resolution but cover a bigger surface. So it looks low res. So how to mediate to get rid of that is actually maybe increasing the amount of cascade shadow between the two, or just increase the overall resolution, if you can. And then you get to those type of open world situation where even with a cascade shadow, it's still way too low resolution. So you might want to actually use distance fill for that case. Okay, directional light, stationary area shadow. What does that mean? So by default, the directional light, they are extremely sharp. And then by activating the use area shadow for stationary light, what it does is bake those shadow into the light maps. What is allowing us is sometimes you want to do a lighting for an overcast where the source of the sky, the source of the lighting is actually very broad. So this is where you can change in the directional light the source angle, and you can make it up to 10. Let's look at it. So for example, you have on the left side, source angle set to 1, and then the same light with a source angle set to 10, it tends to broad the shadow. It's like an overcast day. Capsule shadow. So what we do is we actually use a physical asset, so those little capsules, to create an approximation to render the character to support soft shadowing. So those are actually really great. We use that a lot in VR because they actually create some very cheap shadow. The biggest problem with those ones is, for example, you have a character that creates shape shadowing, for example, the nose shadowing on the rest of the face. Because we're using a huge capsule shadow, you lose all those details. So if it's important for you, then you might have to not use capsule shadow. But if you're the most important thing is the character casting shadow on the ground, then I would recommend that if you are a very intensive. I would say if you want to optimize very aggressively, switch to capsule shadow. But they also use for other things, for the indirect shadow. So sometimes you have the character that is actually standing in the shadow, and you need to have that sort of AO, ambient occlusion, and then this is where the capsule shadow are really useful. It gets so what it does is use the probes that we saw earlier in the bake lighting. Those are spherical harmonic, and then that gives an indication of where is the shadow should be projected on the world. Ray trace contact shadow. So that's a pretty new feature. So again, going back to the bias, sometimes you need to have a bias that's pretty large, but you still want to get some very nice shadow on smaller object. So now we have something that's actually named contact shadow length. So by putting that value pretty small, then you start to get and retrace. You do sort of ray tracing, and then you start to get those detail on smaller scale object or asset. So it's pretty useful. I think it's a bit expensive. Reflection. So the high resolution reflection capture. So that's something that's new too that we had to create. So by default, I think the resolution capture are 64 or 128. And then as you can tell on the left side, it gets some very blurry reflection. And then By increasing that, you're actually increasing by a lot the memory, so be careful when you change that. It's not free. But you get a lot sharper reflection. Why is it useful? We introduced that for the demo that we did with McLaren, where we needed to have a very nice and sharp reflection on the cars. Planar reflection. So those are really useful. So what it does is actually create an asset, the planar reflection actor, and then what you do is it's going to reflect everything in the world based on that planar. So it's actually mirroring it. So it doesn't work for anything that is hills. It just works on something that is purely planar. So the good thing is you can optimize those. You can say, hey, you don't need to reflect the entire world. I'm just reflecting those specific assets, because it can get really expensive. So what you want to do is make sure the overall lighting, the overall reflection looks good with the capture reflection. And then when you want to have extra detail, then you add those planar reflection. And then you have a list of assets on the right, and you say, I want this one, this one, this one. The one that makes the most sense, and the one that makes the most change in the picture. And then another way to optimize that is you can have actually several planar reflection. In RoboRecall, it was something that worked well for us because we teleport. So by teleporting to another place, we turn one off and then activate another one. But there's probably other way to optimize that by switching from a room to another room and turning it off. And then the last thing is bent normal. That's a new feature that we have. So what it does is actually act as a reflection occlusion. So if you bake your character in the T-pose, now you start to have bent normal that would occlude the reflection. What it does is it avoids some light leaking from the reflection capture, basically. So I'm running out of time, so I would say I recommend you to dive into that. It's very useful. And then what's coming up for the new feature in Unreal Engine? So we're gonna have a new way to sample, to use the probes, the light volume sample. So they will be now a lot more accurate. And then we have now we're gonna have a skylight that will use QMap instead of spherical harmonic to generate the lighting. So you have you're going to have a lot more directionality in your light. For a sunset, now you're gonna really feel the sunset on your character when it's baked. And then now we finally have the multi-bounce on the skylight, and then also on the MSC object, and then a lot more. So take a look at the 4.18. It's coming up. It's going to be awesome. Thank you. That's it.